Hello, Algebra 2 Honors students. Here we are for our Test 7 review. Okay, first problem. We're graphing. We have y equals 3 to the 3 times 1/2 to the x power. Give this one a try. Come back for the solution. Okay, here's the XY chart we have. We plugged in the numbers -2, -1, 0, 1, 2. You can do this by hand, or if I were you, I would plug it into my graphing calculator to get out the corresponding y coordinates. We plot our graph and then draw our picture. A couple things here. We need to find out what the domain is, what the range, and what the asymptote is. You can do all this before you even graph the picture, but the picture is helpful. Your asymptote is, again, your Kelly point, which in this case, in this problem, is 0. So our asymptote is y equals 0. So then we go to our graph, and we put a dashed line at y equals 0. This is the line that does not get crossed. Then we look at our domain. Domain, again, is all the numbers you can plug into a problem. When you have a graph like this, this means you can plug everything into it. So our domain is all real numbers. And our range with an exponential graph will always, or our range will always work with whatever our asymptote is. So our range is y is greater than 0. And this is what you should end up with. Our next problem, very similar. We have y equals 2/3 to the x power plus 1. This time we're going to figure out or at least our asymptote first before we get started. Our asymptote, again, is our Kelly point, so in this case, 1. So our asymptote is y equals 1. If you just have 1 there, it is incorrect. You need to have the y equals part to it. Okay, now give this one a try again. Plug it into your graphing calculator. Come back for the solution. Okay, this is the graph and the XY chart you should end up with. If you notice, you might be asking yourself, why Miss Teal? Why did you have a -3 there in your x value? Well, that's because when I looked at my table, after I plugged it into my graphing calculator, I saw my points were all kind of close. They were only between 1.4 to 3.25. So I wanted to get an extra point in there to make my graph even better and more accurate looking. So I chose to put the -3 in there as well. So I plotted my points. Our asymptote is +1, so my blue dashed line is there. We're not going to cross that line. Our domain here, what numbers can we plug in? What type of x values can go into this problem? Well, it's everything. So our domain is all reals. Our range, what numbers are we going to get out? Remember, the range with the exponential equations is tied to what our asymptote is. And we're going above these, so it's going to be y is greater than 1. If it went below, that would be y is less than 1. Okay, number 3. The value of a new motorcycle purchased for $22,500 decreases 6.5% per year. Write an exponential decay equation for the value of the car after t years. Then use the equation to estimate the value after 3 years. Okay, our original equation, or our formula for exponential decay, so you can do the problem as y equals a times the quantity 1 minus r to the t power. Okay, so plug in all your values and come back for the solution. Okay, you should have ended up with your answer of $18,391.50. If you got that, you can continue on to the next problem. If not, here's the explanation. We first, here on our blue line with the blue marker, we plug in all the values that we know. Our A is our starting value, so the motorcycle was purchased for $22,500, so that's going to be our A. Our rate is 6.5%, so we need to write that as a decimal, not a percent, so we're going to move the decimal over 2 places, so that's how we get the 0.065. Then our next step here in red, we subtracted the 1 minus 0.065, and we got 0.935. Now, you need to remember order of operations. A couple of us were having issues with this on our last quiz. We need to make sure we do the exponent part here first. So we need to do 0.935 to the 3rd power. We get 0.8174 out. Now also, make sure you're putting enough decimals. Don't just round that to 0.8. You want to make sure that you have enough decimals there to give an accurate answer. You usually need to do 3 to 4 decimals here when we're dealing with exponents. So we take 0.8174 times the 22,500, and we end up with the answer of $18,391.50. Make sure that you do put a dollar sign here. It is a real-life application problem. You do need to label what you're talking about in the problem. We're talking about money, so a dollar sign is appropriate. Okay, next problem. The Bank of Johnson offers certificates of deposits, otherwise known as CDs. The 4-year CD has a minimum balance of $2,200 and pays an annual interest rate of 3.5%, compounded continuously. How much will the CD be worth at its maturation date? So we have our equation is y equals p e to the RT power. That's for the compounded continuously. That equation will be given to you tomorrow on your test, but you need to know that this is the equation you use for it. So plug in all of your values, come back to check your answer. Okay, you should have received an answer of $2,530.66, or approximately there. Again, you can be a little off if your rounding is a little off, or you kept more decimals or kept less decimals, but approximately that much. Okay, if you got that, continue on. If not, here's the explanation. Here in blue, we plugged in all of our values. 2,200 is our starting rate, our principal when we're dealing with this kind of stuff, so that's why we have a P. Our rate is 3.5%, so we move that to a decimal of 0.035. And our time, this is a 4-year CD, and we want to know what it's worth at the end of it, so at the 4-year mark, so that is our T. First step here in red is we multiplied our exponent, the 0.035 times 4, to get 0.14. Then we plug in our calculator e to the 0.14 power. So here in black, we have 1.1503 as our decimal. We're multiplying that times our original amount that we put into the CD, which was $2,200, and you should get the answer of $2,530.66. Okay, next problem, evaluate. First of all, I saw some of you guys in class here doing the change of base theorem. There is absolutely no reason why you should be doing the change of base theorem. You'll get the right answer, but you should know this without doing that. These are numbers that you should know in your head with your exponents and powers. So you should not be doing the change of base theorem. I'm going to challenge you guys on the test to do them without the change of base theorem. Try them by just knowing your powers. You can check it with the change of base, but try it without it first. Okay, so here we go. I'm going to rewrite this so it's an exponential form, because exponential form makes a little more sense to me personally. So 2 to the x equals 1 over 32. So we know it starts off as a whole number and then gets turned into a fraction. In order for something to happen to do that, that means our exponent needs to be negative, because remember, a negative flips it into a fraction. So then you just need to know 2 to what power is 32. This one you should know. We see it a lot. We see it all the time, is 5. So our answer is -5. For the next one, I'm going to again rewrite it. So it's 5 to the x power equals 125. This is just a straight up problem. 5 to what power is 125? Again, you should know this. It is 3. Third one, we have log base 9 of 1 over 729. So again, I'm going to rewrite it. So 9 to the x equals 1 over 729. It gets turned into a fraction. So again, that means our answer has to be negative. And 9 to what power is 729? You might not know this one off the top of your head, although it is one of the ones I had you remember at the beginning of the year, and that is to the 3rd power. So our answer is -3. Our last one, rewriting it, is 3 to what power equals 2,187. Now, you're probably not going to know this one off the top of your head. I wouldn't know this one off the top of my head. So I'm just going to guess and check. I know 3 to the 4th is 81, so it has to be bigger than 4. So I'm just going to guess and check until then, and I get 3 to the 7th power is 2,187. Okay, find the inverse of the functions. These were interesting for quite a few of you guys in class today during the review time. So give them a try. The first one is y equals log base 7 of x plus 6. The second one is y equals log base 11 of the quantity x minus 2. So stop, give these a try, and then come back for the explanation. You will have to do these on your test tomorrow. Welcome back. Our first one here, our first step when we're trying to find inverses, knowing what we did in Unit 6 here, our first step is to switch the x and the y. So x equals log base 7 of y plus 6. After this, we should know our goal, our ultimate goal in this is to get the y by itself, solve for y. So we want to get the term with the y by itself. So in order to do this, we need to subtract 6 to both sides. So we get x minus 6 equals log base 7 of y. Now right here in log form, there's nothing else we can do. So if we can't do anything in log form, let's see if we can put it in exponential form and see if that helps us out at all. So our base is 7. Our exponent is what's over here by itself, x minus 6. And that equals the y. We just solved for y, so we are done. That is your answer. Okay, next one, same process, but slightly different answer at the end. So we have y equals log base 11 of the quantity x minus 2. We're going to switch our x and our y values first off. So x equals log base 11 of y minus 2. Here we can't add, some of you guys were trying to add the 2 to the other side, but you can't do that because it's in parentheses attached to that y with that log right now. So right now we can't do anything. So we're going to turn this around and put it into exponential form. So we have 11 to the x equals, now the log goes away and we're just left with y minus 2 over on the right hand side. So now we can move the 2 away from the y. So we're going to add 2 to both sides. And so we're left with y equals 11 to the x plus 2. And that is your answer. Yay! Okay, a couple more graphing problems here. And this time we're going to be graphing logarithms. Remember when we're graphing logarithms, we usually want to plug our numbers into our y value. So on my xy chart, I'm going to plug into 0, 1, 2. So stop the video, give yourself a chance to do this problem, and come back. Okay, these are slightly different to do these. First of all, we want to find our Hankin-Kelly point. Our Hankin-Kelly point is the point 0, negative 2. After we find our Hankin-Kelly point, we're going to kind of forget about the Hankin-Kelly in the actual equation. We're going to rewrite it into exponential form. So we have e to the y power equals x. That's why we plug numbers in for the y value, because y is our exponent. So we plug in 0, 1, and 2 in for the y. We get a 1, 2.7, and 7.4. We graph those. These are the blue points on the graph if you can see them. And now we're going to translate using the Hankin-Kelly point. Our Hankin-Kelly is 0, negative 2, so that means we are going to go right and left is 0, and then we're going to go down 2. So we're going to take each point and translate it down 2 places. So our actual graph is what's here in red. Now before I graph my line through those red points, I want to go through and do at least my asymptote. Our asymptote is always going to be what is dealing with our Hank value, what's positioned with the x. In this case, it's nothing, so it's x equals 0. Remember when we're graphing the logarithms, including this natural log one, that our asymptote is a vertical asymptote going up and down. So here in green will be our vertical asymptote going up the y-axis like that. And then we're going to go and color through our red points, putting arrows on the both ends of both of those. Our domain, when we're dealing with logarithms, is going to be tied into our asymptote. So our domain is x is greater than 0, because if you notice, we have no points over here, do we? So those would be all the negative values, so we only have positive values. Our range, we can get anything out of this equation, so our range is all reals. Okay, the next one is very similar to that, except it's a regular log. So we have y equals log base 3 of the quantity x plus 1 minus 2. So first thing off, you're going to find your Hankin-Kelly point, find your asymptote, give it a try, come back to see it completed. Okay, here's our solution. We first found our Hankin-Kelly point was -1, -2. So we take that out, and then we kind of forget about that when we're dealing with the actual equation. So we turn it into exponential form. So 3 to the y equals x. We plug in 0, 1, 2 in for our y values, getting us out 1, 3, and 9 respectively for our x's. We plot those points on our graph. Those are the blue dots on our graph. We then now deal with the Hankin-Kelly part of it. Our Hankin-Kelly was -1, -2. So we're going to move each point to the left 1 and then down 2. So those are my red dots. I then connected them all with my red arrowed line. Also with this, our asymptote is our Hank, which is -1. So my green line is dashed going up at -1. That's the line we do not cross. And our domain is x is greater than -1, and the range is all reals. Okay, next one. A biologist is culturing a new species of bacteria. She finds that the equation y equals 23.4 e to the 0.56 t models the growth of this new species accurately, where y is the number of bacteria in millions in the culture. How many hours will it take for there to be 760 million bacteria in the culture? So we need to figure out where we want to put things. We want to find out, we're looking for how many hours will it take. So we want to find the time. So that's going to be our variable in the problem. So that means this 760 is going to go in for our y. So 760 equals 23.4 e to the 0.56 t power. So we want to isolate the t, which means we need to isolate the e, and e is being multiplied by 23.4, so we're going to divide both sides by 23.4, giving us an answer here of 32.479 equals e to the 0.56 t. Now here in exponential form, we really can't do anything else with this, so we're going to turn it into, that's correct, logarithmic form. Now we have base e, so that means when we turn it into logarithmic form, it's not a regular log, it's our natural log. So the natural log of 32.479 equals the exponent of 0.56 t. So in our calculator, we do the natural log of 32.479. We get out 3.4806, and that's equal to the 0.56 t. We're going to now divide both sides by 0.56, and our t is 6.22, and here we're talking about how many hours will it take, so this is 6.22 hours. Again, making sure you label your answer because we need to know what you're talking about. 6.22 what? It's hours. Okay, use the change of base theorem to evaluate the expression, rounded 4 decimal places. This is all calculator work, so you need to make sure you have your calculator handy. You're going to do the log of 346 divided by the log of 13. Plug it in your calculator and make sure you follow the directions and round to 4 decimal places. It is 2.2795. For the second one, again, it's the log of the big number. So log of 1245 divided by the log of the base, in this case 5. So log of 1245 divided by log of 5 gives us an answer of 4.4280. And that would be your answer. Expand the expressions. We want to make these bigger. So here, the g and the h, they are being multiplied. So in logarithms, what does multiplication mean? Naturally, it means addition. So we're going to be adding two different logarithms together. Again, also remember your exponent needs to come out into the front, in front of the logarithms. So we should have 2/5 log base 7 of g plus, same thing with the h to the 7th, we're going to bring that 7 out in front. So it's 7 log base 7 of h. And that's your answer. Part B, same concept. We're going to be expanding this one. We have the natural log of x to the 5th, y to the 8th, sorry, I can't read my own typing here, y to the 8th, divided by z to the 7/5 power. Now this one's a little bit more complicated because we have a division going on as well. When we're dividing with logarithms, that means, yes, that's correct, subtraction. Totally makes sense. So we are going to do the natural, I need to deal with that exponent on there. So it is 5 natural log of x plus 8 natural log of y, because those two are being multiplied. So that means we add their logs together. And then minus 7/5 natural log of z, because that's being divided. It's on the bottom of the fraction. So that means it's being subtracted when we write it out in logarithm form. So that's expanding. So naturally, if we're going to expand some logarithms, we also then have to condense some logarithms. And some of you guys had some questions on this during class today that I didn't quite get to, because we have some simplification we need to do, which we hadn't really dealt with a whole lot with these before. So here we notice they're all log base 8s. So we have log base 8. I see a subtraction, so that means I know I'm going to have a fraction, so I'm going to go ahead and write that fraction sign down. And then our exponent is here, so this becomes 9 to the 4th, x to the 3rd, subtracted, so this means this is going to be coming on the bottom, and this is just a 27. Now, I don't want you to keep it just like this. We need to simplify it. So we're going to have log base 8, 9 to the 4th power. I by no means expect you to know that one. Put that in your calculator. It's 6,561. And then we have x to the 3rd over 27. Now, if you give me that as an answer, you'll get most of the credit on a quiz or a test, but you're not going to get it all because we always want to make sure we simplify our fractions. So we have log base 8, and then 6,561 divided by 27 is the glorious answer of 243. And then we still have this x cubed with it. And that is your final answer for that condensing problem. Next one is very similar. We are going to do the same process. They're all the same base. They're all log base 6. We also see that there's a subtraction sign in here, so I'm going to make a fraction sign right away. The number in front becomes our exponent, so it becomes 4 to the 3rd, and then y squared, and then 2 to the 5th power. So we have log base 6. 4 to the 3rd power is 64. And then y squared. And then on the bottom, 2 to the 5th is 32. So we have log base 6. We're going to simplify this fraction part. 64 divided by 32 is 2. So we have 2y squared. And that is your final answer. Yay! We're getting in the home stretch here. Okay, for number 13, we're solving, for the next 3 slides, we're solving exponential and logarithmic equations. So again, our entire goal is to get the variable by itself. On this first one, we have 5 e to the x plus 3 equals 38. So the first step, what do you think it is? Yep, that's correct. We're going to subtract 3 to both sides. So we have 5 e to the x equals 35. Now we still want to get the e to the x by itself, so we want to divide both sides by 5. So if we have e to the x equals 7. Now this is where some of us are struggling in class because we don't know what to do from here. You're looking at it going, I don't know, Miss Steele. Well, this is an exponential form, so this is always your fallback. If something's in exponential form and you don't know what to do with it, try putting it in logarithmic form and see if that helps out. Same goes with the reverse. If something's in logarithmic form and you don't know what quite to do with it, then you're going to turn it in to exponential form. So we're going to turn this into logarithmic. It is a base e, so that means it's our natural log. It is base e. All natural logs are base e, so we don't need to write the base e. Of 7 equals x. And looky there. We have our variable on one side of the equation all by itself. So now it's just a matter of plugging this in your calculator, doing the natural log of 7 to get 1.946 equals x. And that is your answer. Second one, very similar to that, so give this one a try. Just so you can check your work, you should end up with an answer of 2.303. So if you got that, continue on to the next slide. We're going to add 7 to both sides. So we have 2e to the x equals, that's a 7, not a 2, Miss Jill. 13 plus 7 is 20. Divide both sides by 2. E to the x equals 10. Again, you're in this position that you're in exponential form and you can't really do anything. So we're going to turn it into logarithmic form. So the natural log of 10 equals x. Plug that in your calculator. You should get 2.303 equals x. And there you go. Okay, number 14, we have an a and b again. For a, we have the natural log of the quantity 5x minus 2 equals natural log of the quantity 3x plus 6. Because these are both natural logs and they're equal to one another, that means these parts in parentheses are equal to one another. So we're going to set them equal. So 5x minus 2 equals 3x plus 6, and then you're just going to solve for x. So we're going to subtract 3x to both sides, add 2 to both sides. So we end up with 2x equals 8. Divide both sides by 2. And x equals 4. Oh, I should probably not have boxed it up because I do need to go and check my work. I forgot to be a good role model there and check it first. So we put a 4 in here. 5 times 4 is 20. 20 minus 2 is 18. Plug it into the other one. 3 times 4 is 12. 12 plus 6 is 18. They are equal, so we are good to go. Also, they are both positive, and those numbers in those parentheses need to end up being positive. Okay, next one. These are log both base 3. So again, we're going to set their parts equal to one another. 10x minus 6 equals 2x plus 10, and solve. Subtract 2x to both sides. Add 6. So we get 8x equals 16. Divide. We get x equals 2. Again, go back and check. So plugging in the 2 here. 10 times 2 is 20. 20 minus 6 is 14. Plugging in 2 to the other side. 2 times 2 is 4. Plus 10 is 14. Those are equal. They're both positive. So yay, we are good to go. Okay, last one for this target. We have log base 4 of x minus 3 plus log base 4 of x minus 4 equals 1/2. So we are adding logarithms, so that means that we have to, yes, that's correct, multiply them. So we have log base 4 of x minus 3 times x minus 4 equals 1/2. We are then going to turn that into, we're going to distribute out and do the math F word, the foiling that I'm not supposed to talk about. We're going to do that here in the middle. So we're going to end up with log base 4 of x squared minus 7x plus 12 equals 1/2. And that needs to go in parentheses. Okay, now we are going to turn this in to exponential form. So we have 4 to the 1/2 power equals x squared minus 7x plus 12. 4 to the 1/2, remember when you have a fraction as an exponent, we learned that last unit, that means it's really a root. So this means the square root of 4 The square root of 4 is 2. So I'm going to take the 2 to the other side. So we end up with 0 equals x squared minus 7x plus 10. Now we're going to do your guys' math F word and factor. We're going to factor these two numbers, the reverse of FOIL. What numbers multiply to be 10 and add to be negative 7? We guys need to start remembering how to do this because this is going to come up a lot in Unit 8. So it's going to be x minus 5, x minus 2. We're going to set both of those equal to 0. And we get x equals 5, x equals 2. Plugging them in to check. 5 minus 3 is 2. 5 minus 4 is 1. 2 times 1 is 2. So 4 to the 1/2 is 2. So we're good to go. Plugging in the 2 into the equation. 2 minus 3 is negative 1. Uh-oh, stop right there. Hold the presses. Can't do that. You have a negative there. So 2 does not work. X has to equal 5. Okay, try the other one here on the screen by yourself. We have log base 3 of x plus log base 3 of x plus 8 equals 2. Okay, for this part B, you should end up with x equals 1 as your answer. If you did, continue on. If you did not, here's the explanation. We are doing addition, so that means with logarithms that we're going to have to multiply. So we have log base 3 of x times the quantity x plus 8 equals 2. Multiply that out to get x squared plus 8x. Then we turn it into exponential form, so we end up with 3 squared equals x squared plus 8x. We want to get everything to one side where the x squared is positive, so we're going to do 3 squared is 9. We're going to subtract it over to the other side. So we're left with our last blue line there, 0 equals x squared plus 8x minus 9. Then we need to factor. Yes, that's right, factor again. So what numbers multiply to be negative 9 and add to be positive 8? And we end up with x plus 9 and x minus 1. You set both of those equal to 0, so you get x equals negative 9 and x equals 1. You go back and check them. Negative 9 doesn't work because you plug in negative 9 plus 8. That's negative 1. You got a negative right away. That one does not work. You plug in 1 and it does work. Yay! Okay, 2 more problems, people, and then we will be finished with this. Yay! Okay, write an exponential function, y equals a times b to the x, whose graph passes through the points 112 and negative 1 3/4. And show all your work. So I don't want you doing this one in your calculator. I want you to do this one by hand. So we substitute them in, each point separately. So 12 equals a times b to the first, and then 3/4 equals a times b to the negative 1. There's multiple ways and processes to do this problem. This is the one I chose. So we're going to take this first equation here, and we're going to divide both sides by b. So a equals 12 over b. We're then going to take that and plug it into the a in the other equation. So 3/4 equals 12 over b times b to the negative first. Okay, so now we get 3/4 equals. I'm going to flip this because this has a negative exponent. I'm going to flip it down to the bottom with this other b. So I'm going to end up with 12 over b squared. Now we have two fractions that are equal to one another. So we're going to do something we haven't done in a while, and that's cross multiply. So we have 3b squared equals 48. So b squared equals 16. Square root both sides, and b equals 4. We're then going to take that and plug it in here. So 12 over 4 equals a. A equals 3. And then we want to write our final answer in the correct form. And don't forget to do this part. A couple of us did on our quiz yesterday. And you got points taken off. So you get y equals 3 times 4 to the x power. You got to do that as your last step and put it into an equation. You can always check your work by then plugging this into your graphing calculator, doing the stat edit, plugging them into your L1s and L2s, and then stat calc. And then this one is an exponential function, so you're going to hit your exponential regression, which is number 0. And you should end up with the same answer here. And the last question on our test, yay, is the following. The table shows the minimum hourly wage in the U.S. since 1960. Let x equal 1 represent the year 1960. So I'm going to cross out this 1960, put a 1. X equals 2 represents the year 1965, and so on. So I'm going to redo these years. And those are the numbers I'm going to plug into my L1 and L2 in my calculator. So we're going to plug these into our L1 and L2 in our stat edit menu. Then you do stat calc, and this time we want a power model. So you're going to hit the power regression button, which is letter A. So you do all that work, you plug all those in, you should get y equals 0.81 x to the 0.79 power. Okay, that's part of the problem. And then it says, use the model to estimate the minimum hourly wage in 2020. So if 2005 is 10, then that means 2010 is 11, 2015 is 12, and 2020 would be 13. So that means we're going to plug 13 into this equation. So y equals 0.81 times 13 to the 0.79. Do this in your calculator, and you will end up with a minimum wage in 2020 of 6.14. Now, that is the review for our Unit 7 test. Yay! You have completed it. Good luck tomorrow on our test.